lesson, we're going to be talking about complex numbers and their operations. So first we need to talk about the imaginary unit I. Since we can take the square root of numbers like 4, so let's say if I take the square root of 4, that means that I'm going to get 2 or I might get negative 2. All right, 2 times 2 is 4 and negative 2 times negative 2 is 4. However, if I try to take the square root of negative 4, there's no two numbers that multiply together by themselves to make negative 4. So we need this imaginary unit I, and it's going to represent the square root of negative 1. So since the square root of negative 1 is I, then that means that I squared would be equal to negative 1. So anytime we see an I squared, we're going to replace that with negative 1. So an imaginary number is any number bi, where b is a non-zero real number and I is the square root of negative 1. Complex numbers are numbers that can be written in the form a plus bi, where a and b are real numbers and I is the square root of negative 1. They all include all real and imaginary numbers, as well as the sum of real and imaginary numbers. So for example, I've got negative 6 plus 4i. Negative 6 would represent my real part, and 4 would represent my imaginary part. So the a would be negative 6, the b would be 4. Or 7 minus I squared to 2. 7 would be the a, and negative square root of 2 would be the b. All right. If I have 0.5i, I obviously don't have an a because there's nothing being added or subtracted to my imaginary part. So a would be 0 and b would be 0.5. So I'm going to solve number 1 using a square root. So I only have this x squared over here. I'm going to square root both sides. Now, when I take the square root, I know that that's going to give me a positive answer and a negative answer. So x is equal to, the square root of 16 is 4, so I have a positive 4, and I have a negative 4. 4 times 4 is 16. Negative 4 times negative 4 is also 16. All right, I'm going to do the same thing over here on number 2. I'm going to square root. I know that I'm going to have a positive answer and a negative answer. So x is equal to plus or minus. Now here's the problem. I know that the square root of 9 is 3, but I have that square root of a negative. So I'm going to think of this as the square root of 9 times the square root of negative 1. Well, I know that 9 is a perfect square, so I get 3. And because we've defined what an imaginary unit is, I know that the square root of negative 1 is I. Anytime I take the even root of a negative, I'm going to have I. So every time I square root a negative number, I will have an I in my answer. Number 3. I'm going to take the square root of both sides. I know that I have a positive and a negative answer. So x is equal to plus or minus. Now again, I know that I have the square root of a negative, so I should have an I in my answer. And 5 is a prime number, so even if I split this into the square root of 5 times the square root of 1, negative 1, I know that 5 is a prime number, and I can't reduce the square root of 5 at all, but I know that this is I. Well, I don't put the square root in front of anything, so I'm going to change this to I times the square root of 5. So always put your square root behind everything else. All right, the square root of x squared, I'm going to square root both sides. I know I have a positive and a negative answer. So x is equal to plus or minus. Now again, I'm square rooting a negative, so I know that I'm going to have an I in my answer. But 72, I need to do a factor tree for. So 72 is 9 times 8. 9 is 3 times 3. 8 is 2 times 4. And 4 is 2 times 2. So I have 1, 2, 3 2's and 2 3's. Now the 3 squared is a perfect square, but 2 to the third is not. So I'm going to use 2 of those. I will leave a 2 left over, and then I have my 3 squared. So I have the square root of 2 squared times the square root of 3 squared times the square root of 2. The square root of 2 squared is 2. The square root of 3 squared is 3. And then I still have that prime number 2 left underneath the root. 2 times 3 is 6. So I've reduced the square root of 72 to 6 square roots of 2. But then I still have that negative 1. Now remember, the square root of negative 1 is I, so I can replace this with I. But I don't want to put 6 square roots of 2I, so instead I'm going to kind of treat I like a variable, even though it's not a variable, and put it with my 6 so that my root comes last. So this would be a positive and negative 6I square roots of 2. All right, now when you find the sum or difference, it's just like finding the sum or difference of anything else. You add or subtract like terms. So here I have 6 minus 2. Well, 6 minus 2 is 4. And then I have 8I minus negative 5I. Well, if I do 8 minus a negative, that gives me a positive. So 8 plus 5I gives me 13I. And then you always want to list your real part first and your imaginary part at the back. We want them in the form a plus bi or a minus bi. Here I have 4 plus negative 11, which would be negative 7. And then we have negative 7i plus 9i, which gives me 2i. You're really just doing like parts. So negative 4 plus negative 2 would be negative 6. And 6i plus negative 9i is negative 3i. 3 minus negative 4, that's going to be a positive. So 3 plus 4 is 7. Negative 2i minus I would be negative 3i. So the adding and the subtracting is actually not bad at all. All right, then we're going to do the product where we multiply things together. Now this is where we need to remember that when we have I squared, that is equal to negative 1. And that's because we know that if we took the square root to get rid of that square, we would have the square root of negative 1, which would equal the I. All right, so I squared, anytime we see I squared, we're going to replace it with negative 1. So to find the product, and it says write in the form a plus bi, we're just going to do these like we would do any other problem. So I have a negative 2.5i times 8 minus 9i. So I'm going to distribute and do negative 2.5i times 8 would be negative 20i. And negative 2.5 times negative 9i, I'm going to have an I times an I, so negative 2.5 times negative 9 is positive 22.5, and I times I is I squared. Now I already know that whenever I see an I squared, I'm replacing it with negative 1. So I'm going to write what I have, but I'm taking this I squared out, and I'm going to replace it with negative 1. Now I have 22.5 times negative 1. So I have negative 20i minus 22.5. Essentially, all that does is it just changes the sign, because now, instead of multiplying by I squared, you're multiplying by negative 1. But now I'm done. I have no like terms. This is it. But it's not in the form a plus bi, so I need to put the negative 22.5 in the front and the negative 20i at the back. All right, so at number 10, we have a binomial times a binomial, so we just double distribute. 3 times 3 is 9. 3 times 2i is 6i. Negative 2i times 3 is negative 6i. And negative 2i times positive 2i is negative 4i squared. Well, I already know that I need to replace that I squared with negative 1. I also have some like terms. So 9 does not have a like term right now, so I'm going to leave the 9 alone. 6i and negative 6i, that adds together to make nothing. And then I have minus 4 times negative 1. Remember, we're replacing I squared with negative 1. Now I have 9 plus 4, because negative 4 times 1 is 4. And 9 plus 4 is 13. So I get a real answer here, no i's. So number 11, another binomial times a binomial. So 2 times 4 is 8. 2 times negative 7i is negative 14i. 3i times 4 is 12i. And 3i times negative 7i is negative 21i squared. So 8, again, no like terms as of yet. Negative 14i and positive 12i will go together to make negative 2i. And then we have to replace this I squared with negative 1. So we have negative 21 times negative 1. Now I have 8 minus 2i. Negative 21 times negative 1 is positive 21. And now I have like terms 8 and 21. And I want that to go in front because I need my I to be the term at the back so that I'm in the form A plus or minus BI. 8 and 21 make 29. And then you have that minus 2i. So here we got a complex number because we have a real part and an imaginary part. So 1/2 times 1/2 would be 1/4. 1/2 times negative 2i would be a negative I. 2i times 1/2 is I. 2i times negative 2i is negative 4i squared. All right, I have a negative I and a positive I. Those are going to cancel and make 0. So I have 1/4 minus 4 times, replace the I squared with negative 1. Now I have 1/4 plus 4, which gives me 17/4. Now, I don't know if you've noticed this or not, but this is the same thing as number 10. Since these two were conjugates, meaning the front part's the same and the back part's the same, the only thing that's different is the sign in the middle. My middle terms canceled out, just like on number 10. My middle terms were a negative 6i and a positive 6i. They canceled out. And in the end, all I have is a real number. So let's talk about complex conjugates. We kind of just touched on that when we talked about those being conjugates. Complex conjugates are complex numbers with equivalent real parts and opposite imaginary parts. Their product is a real number. So for example, if we have 7 minus 8i, the conjugate would be 7 plus 8i. If we had negative 2i, the conjugate would be, or negative 2 plus I, the conjugate would be negative 2 minus I. So we're going to find the quotient. So we're dividing these, and we're going to write it in the form A plus BI. Now, the thing with the dividing is we don't like to leave any i's in our denominator. And the way to cancel out an I, as we saw in number 10 and number 12, is you use a conjugate. You want to multiply by the conjugate. So I don't want this I in the denominator. So since I have 2 minus I, I'm going to multiply by 2 plus I. But I can't change the value of this quotient. Therefore, I have to do the same thing to the top. Because essentially, if I take and multiply by something that is the same on top and bottom, I'm really just multiplying by 1. It's not changing anything. We're just rewriting it. So now I have 10 times 2 is 20. And 10 times I is 10i. On the bottom, we have 2 times 2 is 4. 2 times I is 2i. Negative I times 2 is negative 2i. And negative I times positive I is negative I squared. So on the top, there's really nothing left for me to do there. I don't have any like terms. It's already written in A plus BI. On the bottom, anything with an I should go away because I've used the conjugate. Well, I have 2i and negative 2i. I know that's going to cancel. I also know that I need to replace this I squared with negative 1. So now on top, I have 20 plus 10i. On bottom, I have 4 minus negative 1. That would be plus. 4 plus 1 is 5. So now I'm going to write this in the form a plus bi. So I take 20 and divide it by 5 plus 10 and divide it by 5, and then I'm going to keep my I behind. 20 divided by 5 is 4 plus 10 divided by 5 is 2i. All right, if we look at number 14, again, I want this I gone, so I'm going to multiply by the conjugate of 2 minus 6i, which would be 2 plus 6i. And if I do that on the bottom, I have to do it on the top as well. So 80 times 2 is 160. 80 times 6i is 480i. And then the bottom, I need to multiply the 2 minus 6i times the 2 plus 6i. 2 times 2 is 4. 2 times 6i is 12i. Negative 6i times 2 is negative 12i. Negative 6i times positive 6i. You do the negative 6 times the 6 is negative 36. And I times I is I squared. Now, if you would like to not have to write this and write it and write it, when you get to this one, you could take that out to the side and say, well, if I have negative 36 and I replace the I squared with negative 1, that gives me positive 36. And then you could just know that this was going to be positive 36 right here. It keeps you from having to rewrite a whole step just for that one thing. So on top, I have 160 plus 480i. On the bottom, I know that my 4 and my 36 are going to go together. That makes 40. And that the 2 in the middle should cancel. My 12i and my negative 12i cancel. So now I'm going to take the 160 and divide it by the 40 plus, and then do my 480 divided by 40. Make sure you put that I at the back. 160 over 40 is equal to 4. And 480 divided by 40 is 12, and then you have your I. All right, so on number 15, again, I don't care about the top. I only care about the bottom. I don't want this I right here in the bottom. So I'm going to multiply by the conjugate, which would be negative 1 minus 2i. And if I do that on bottom, I have to do it on top so that I'm not changing the values of anything. And then I'm going to multiply the 4 minus 3i times the negative 1 minus 2i. So 4 times negative 1 is negative 4. 4 times negative 2 is negative 8i. Negative 3i times negative 1 is positive 3i. And negative 3i times negative 2i is going to give me positive 3 times 2 is 6. I times I is I squared. All right, on the bottom, we have negative 1 times negative 1 is 1. Negative 1 times negative 2i is positive 2i. 2i times negative 1 is negative 2i. And 2i times negative 2i is negative 4i squared. Now again, instead of rewriting and rewriting and rewriting, if I want to do 6 times negative 1, that gives me negative 6 here. And then negative 4 times negative 1, that gives me a positive 4 here. I can do that. That's fine. Negative 4 and negative 6 make negative 10. And then negative 8i plus 3i gives me negative 5i. On the bottom, the 2 in the middle should always cancel if you've done this properly. And then you have 1 plus 4, which is 5. So we have negative 10 over 5 minus 5 over 5 times I. Negative 10 divided by 5 is negative 2. 5 divided by 5 is 1, so we get negative 1 times I, which is just I. All right, on the bottom of 16, all we have is the imaginary number. So the conjugate would just be negative 3i since we have a positive 3i. So I will multiply top and bottom by negative 3i. So I have 2 terms times this singular term over here. So we'll distribute that. 6 times negative 3i is negative 18i. And negative 3i times 12i would be negative 36i squared. On the bottom, 3i times negative 3i is negative 9i squared. So if I did negative 36 times negative 1, that would make this positive 36. If I did negative 9 times negative 1, that would make this a positive 9. So on the top, I'm going to put my 36 in the front and my negative 18i at the back. And on the bottom, I just have 9. And then we've got 36 divided by 9 minus 18 divided by 9 times I. 36 divided by 9 is 4. 18 divided by 9 is 2. And then we have our I. Sometimes they don't divide evenly, and that's fine. All right, I believe the next two examples will show us that. So I don't like that the I is in the denominator, so I will multiply by the conjugate, which would be 1 minus 3i. And I'm going to do that on the top and on the bottom. So I have 4 minus 4i times 1 minus 3i. 4 times 1 is 4. 4 times negative 3i is negative 12i. Negative 4i times 1 is negative 4i. Negative 4i times negative 3i is positive 12i squared. On the bottom, 1 times 1 is 1. 1 times negative 3i is negative 3i. 3i times 1 is positive 3i. And 3i times negative 3i is negative 9i squared. So I know that if I take 12 times negative 1, I'm going to get negative 12. And negative 9 times negative 1 is going to give me a positive 9. So on the top, we have 4 and negative 12, which is going to give us negative 8. Negative 12i minus 4i is negative 16i. On the bottom, the 2 in the middle should cancel, and they do. 1 and 9 make 10, so I have negative 8 over 10 minus 16 over 10i. Negative 8 over 10 reduces to negative 4/5, and 16 over 10 reduces to 8 over 5, and we have our complex number. All right, I don't like the I being on the bottom on number 18, so I'm going to multiply by 6 minus 2i because that's the conjugate. We always multiply by the conjugate. 5 times 6 is 30. 5 times negative 2 is negative 10i. 6 times 6 is 36. 6 times negative 2i is negative 12i. 2i times 6 is positive 12i. And 2i times negative 2i is negative 4i squared. So I don't have an I squared on top this time. So those will remain 30 minus 10i. On the bottom, I already know that this is going to be negative 4 times negative 1, which would give me positive 4. So 36 and 4 make 40. 12i and negative 12i cancel. And then I'm going to do 30 over 40 minus 10 over 40. 30 divided by 40 will reduce to 3 over 4. And 10 over 40 reduces to 1 over 4. And then we have our I. All right, so let's use what we have just learned to solve. So I only have this 1y squared here, all right? So first I'm going to subtract 4. That leaves me with 49y squared is equal to negative 4. I will divide by 49. Now, sometimes it might be useful to reduce. This one does not reduce. Sometimes they do. But I noticed that my bottom number is already a perfect square, and I don't want to be left with any kind of root down there. So I'm going to leave it even if it did reduce. So I'm going to square root, and I will have two answers, a positive and a negative. Now, I know that I can do the square root of the 4 on top and the square root of the 49 on the bottom, but I know that because of this square root of the negative, I'm going to have an I. So square root of 4 is 2, the square root of 49 is 7, and then because I square rooted a negative, I have an I. All right, same thing on number 20. I'm going to start by subtracting 81. Now I have x squared is equal to negative 81. I'm going to take the square root so that I can isolate that x. I have a positive and negative answer. Now 81 is a perfect square. That's 9, and the square root of the negative gives me an I, so my answer is 9i. So I have a positive and negative 9i.